The broadcast is now starting. All attendees are in listen-only mode.
Hello, on behalf of Sigma-HSE, thank you for joining us today for our dust hazards webinar covering explosion risk mitigation. We want to give everyone an opportunity to jump into the session, so we will get started in precisely 2 minutes. Hello again, everybody. Thank you for joining us today for our webinar on explosion risk mitigation for dust hazards. I am Mark Yukich, U.S. Technical Development Manager at Sigma-HSE, and I will be your host today. I have approximately 10 years of process safety industry experience. That experience includes combustible dust, flammable vapors, and chemical reaction hazards, and steps to mitigate those hazardous materials while in process. Our team excels on taking the time to understand the pain points for our customers related to process safety. If we don't have the tools to assist, we will ensure that you are handed off to a team that we trust to bring value in meeting your safety goals. Please feel free to contact me directly should you ever need any assistance. Sigma-HSE is a global engineering firm with technical experts supporting companies around the world by providing actionable solutions to protect, enhance, and optimize their process. Our goal is to allow your team to focus on what really matters: protection for your people, business, workplace, and the environment. In this webinar, we will discuss dust hazards and simplified mitigation of explosion risks in industrial operations. This webinar will explore the dust explosion pentagon, testing, DHA, or dust hazards analysis, and hazardous area classification. We will have time for Q&A at the end of the session. Feel free to add questions to that section during the training, and we will address those at the end of our program. Vinny Samois will be our process safety consultant leading our discussion today. Vinny, I will turn it over to you.
Thank you so much, Mark. My name is Vinny Samois. I'm working with Sigma as a process safety consulting lead. I have over 24 years of experience in safety, engineering, and process safety more precisely. That includes anything like DHAs, hazardous area classifications that we're going to be going today. In addition to that, I have experience in facility siting, incident investigation, auditing, PHAs, etc. The idea of today's webinar, as Mark highlighted, is an introduction to dust hazards. So understand what they are, why we need to address them, why we look after them, and try to mitigate what could be a potential issue, the standards that normally are used in the US, and then we're going to talk a lot about dust testing, DHA, and hazardous area classification. And we're going to highlight why the importance of each one of those and why we're focusing on them. And the industry has been trending to focus a lot more for the last several years. So, and a lot of this has to do with the incident data, right? So if we look back in the mid 2010s to like from them to now, there's a significant decrease in the quantity and the amount of fires and explosions, and of course, resulting to that injuries and possibly fatalities over the course of the years. In the graph there, you have like the United States, Canada, and well, the data in international. Again, a lot of things, we can take some of it, but not all the data is going to be precise, because a lot of things there is things that countries that will not record in the past, they start recording. So the international is a little bit of a bigger mix. The trend that I want to highlight is basically the United States and Canada, because those have been recorded for a while now. So this data gives us an average of 28 dust explosions per year, which leads to around 25 injuries and a range of 1 to 6 fatalities over the last several years. And that, if we go back to even further back, like 8-10 years ago, that's what it does. So we exclude the dust fires from this, because a lot of times you just have the fire and that's it, vocalize and all. So we got more in terms of the fires and explosions, in terms of flash fires and explosion side of things, because those are usually the ones that have significant impact. Once we say about fires, flash fires and explosions, there's a little bit of topic that I want to touch, which is what Mark was talking about, the pentagon in the beginning, because all starts with the triangle. If you think about, I have an oxidant, I have an ignition source, and I have the fuel. With those three, it's what I need to generate a fire. With that fire, great. It's localized. It's just looking into that specific area there. Once we start tossing the conversation about dust clouds or vapor clouds, for all that matters, any kind of that, we're talking to a dispersion. So that cloud is not steady anymore. It moves. It creates a little bit of an envelope. And then if we have that ignition, at that point, we have the oxidant, we have the fuel, we have the ignition source, and we have this dispersion, we're now talking about a fire, a flash fire, which basically is a cloud fire. So if you think about anyone in that area, will be like severely hurt, severely injured, and possibly a fatality. So that's where the importance of like trying to do good housekeeping, and we're going to talk about this further down, because we minimize those possibilities of those dust clouds. Once we toss an extra area in there, which is the confinement and congestion, then we're talking about a possible explosion. What generates an explosion is the cloud catches fire. That cloud accelerates enough to generate an overpressure. The way that this happens is by having congestion and confinement. So think about, it's a very simple example. If you think about like putting a little firecracker inside the box, the bang is much bigger. Why? Because it's congested, right? So that's the same idea. So the more you have, the more the flame accelerates, the more generates speed, and the more you reach towards the maximum pressure that can be generated from there. The way that we need to look to prevent those fires and explosions is basically we need to take one of those edges of the pentagon, the square, or the box, or the triangle, if you think about it. So for explosions, the simplest way is by taking the confinement. So if we take the confinement away from that, the explosion is gone, right? Because I don't have enough to accelerate that flame and actually get this to be ignited. The next one is to get rid of the flash fire. How do we get rid of the flash fire? By taking the dispersion out of it, right? So if I take the dispersion out of that, there is no flash fire. And how can I do that? As I mentioned, good housekeeping. Be sure that your system does not let dust out. Be sure that whatever dust is there, I take care of it. I do a good housekeeping. There's no dust settling that can generate a cloud. And then last but not least, if for me to get rid of the fire, I need to get rid of either the fuel, the oxidant, or the ignition source. Let's be honest, getting rid of the fuel is almost impossible, right? The only way is if we replace the material that we're working on, and there are some processes that we can't. It's just a single material that we need, and we're gonna need it. For example, if we're doing bread, we need the wheat. So needing the wheat, there's no way that I can take the wheat out of it and do something different. So that's just one example. So that's when we're talking about a lot of ignition sources, taking ignition sources out of the equation. Be sure that we know what the the conversation is going to be later on, is the testing. Be sure what's the maximum ignition energy that I need for that material, because with that, I know my ignition source is present cannot have over that ignition, that energy. So this is kind of what we got to talk about in a little bit. So things like very simple, like just one of the things and why the test is expected is that a lot of times we get ignition of things that we least expect. So CSB has this video, which is about iron. So it's just like iron dust testing. They release a little bit of dust of iron and they have an ignition source and you got to see what happens. So the idea is exactly to see, we're going to see in real speed and we're going to see in slow motion as well, both of them, and you're going to see how they catch. And you can see in slow motion the little bit of particles that get ignited. So this is one of the things that we're talking about as being extremely important for the for our testing and so far on, is because we want to be sure that we understand what's the hazard associated with that chemical or that dust or that particulate, right? So all great. We saw the fire, we saw this, and we can talk about explosions and so far on. But there's one thing that I want to highlight that is one of the things that we really need to take into account when we're talking about grain dust explosions originated from a fire or a primary explosion, right? This primary explosion, what happens is that it actually basically disturbs the dust that is there. So if you think about it, that you have a dust layer in an equipment and an explosion on a nearby equipment, or even like say, it's like I have a venting panel. The venting panel releases that. Just the release of that can disturb that dust, and then it creates a secondary cloud, right? The secondary explosion is when we got ignition on this dust that is disturbed, and that tends to be a much more severe impact. So that's the importance of understanding that, right? So great. So now I want to talk about what standards. What do we use in the U.S.? What we use specifically in the industry to try to deal with combustible dust, right? So NFPA actually asks for 4 items or assign 4 responsibilities for 4 things for operators and owners, right? They talk about determine the combustibility and explosibility hazard of the material. That's where the testing comes into. We identify and assess fire, flash fires, and explosion hazards. That's when dust hazard analysis comes into place and the requirement now for MOSHA that we need to carry those. Then we need to manage the identified hazards, so we need to understand what they are, and we communicate them to the affected personnel. So these are all responsibility of operators and owners. They need to identify, they need to be sure that their dust is combustible or not. They need to manage the hazards that were identified, and then we need to communicate to the personnel that can be affected by that. So the commonly applied U.S. standards is all coming from NFPA. You can see that there's 61, there's from agriculture and food. You have 484, which is for metals. You have 664 for wood and some other ones. Some that are straight across the board, there's going to be 68, which is for explosion protection vent design. 499, which is electrical area classification, which we're going to talk about a little bit later, and 652 and 6054. Those are common for everyone and everybody's going to do. What tossed into that is that now NFPA is coming up or came up with 660, which covers all materials. It's a replacement standard. The intention is to eventually migrate all of those individual standards into a single one. So it will basically make your life a lot easier to determine what do I need, how do I need, and which standards I need to follow rather than trying to figure it out. This is just a sample of some of the standards. There's a lot more standards out from NFPA. There's other standards from other industries and other things, like the UK has their own standard for these years and so far on. So all of this is things that we need to take into account, that depend on the country that you are, or depend on where you're doing this assessment, or even the client itself. I myself did several these years over the Americas, basically because of client requirement, even though it's not required by our standards here or our standards in South America. When I went to do this, it's still in there because of the client. So there's not only the regulation, but could be a client compliance too, right? So why do we need to, the first step that we're talking about on that, or the 4 items that we need to deal with, or the operator needs to deal with, is the combustible dust test, right? So the reason why we do is that we need to look into things, right? There's a screening test that's based on UN recommendations for transport of dangerous goods. It's basically to know if the material is explosible or not. And then we have this as a screening that we can say that it's going to be a go, no go kind of test. ASTM has 2 standards for the screening, and we use that, and our lab in the UK and India is well known and know all those standards, apply them, and we do several testings for different clients. So the way for the testing for the combustible dust is that we can actually take historical data, or we can take published data, or we can do the testing. The major advantage about doing the testing is that you're specific to your material, rather than taking a rule, like a generic data over there. So I'll give you an example of petroleum coke. Petroleum coke can have material, can have compositions that are not even combustible to compositions that are combustible. So our lab tests a range, of diverse range, that some of them ignite, some of them don't ignite. And there's a lot to do with the composition. So this is the importance of why you test your own product, so you can ensure that you are explosive or not in your situation. So there's several tests, right, that we can be conducting. The most ones is to figure out the severity, is the minimum explosive concentration. So basically, how much do I need to actually ignite a cloud, right? Explosion severity, that tells me the Pmax, or basically the maximum pressure, KST. And then we have the sensitivity to ignition. So basically that will tell me what's the minimum ignition energy. So how much do I need really to actually ignite that? Then minimal out ignition temperature for the cloud and for the layer. So think about this: if a layer of dust is settling in the equipment, and that equipment is heated and it gets above that temperature, it's an out ignition temperature. So it means that the material ignites. The cloud is the same thing. The cloud reaches up to an area where it's a furnace or something, even without the direct flame, it could still be an ignition. And then the minimum ignition energy tells me that, for example, for sparks, what is it? So if the material is under their minimum ignition, let's say it's brushing or any other type of ignition, it's not reaching, then it's okay for me to have as my housekeeping brushing. If it's not, then I need to take it away and do vacuum systems and so far on. So that's where we got to understand what our material is and what we can play with those in terms of determining what the severity, what the impact will be. Next, I want to talk about the second item, which is to identify those hazards, right? That's where the DHA, the dust hazard analysis, comes into place. Similar to what we talked about before, not too long ago, we have a webinar on PHAs, or process hazard analysis. The DHA is the same approach. You have several ways to do it, and we're going to talk about 2 of them here. One of them is going to be a risk-based, which you define your scenarios, and when we risk rank the scenarios, the other one is a checklist. So those are the most common used ways of doing DHAs. One of the things, it's required by NFPA, that is led by a qualified person. So it's basically someone that has experience, because the better the quality of your workshop, the better the quality of that assessment, the better your results and the more you are aware of it. So that's the reason why asking for a qualified person. It's based on the combustible dust characteristics of the material that we're talking about. We evaluate the hazards and the scenarios, and we provide recommendations in terms of like what can be improved in your system. Because a lot of times we're going to talk about this. We define our scenarios, we define all our safeguards, we look into our mitigations, and the risk is still not acceptable. In that case, we're going to need to provide recommendations to reach that acceptance level, right? It could be simple as, okay, we're going to need to increase ventilation on this area. So if the dust appears, if there is dust present in here and there is, it's not going to be enough in terms of volume of dust to generate a concern for me. So this is things that can be talking about. And of course, all of this is documented into either a spreadsheet or a report that can be reassessed. What needs to be evaluated is, in terms of equipment, every equipment in the process that process combustible dust, we need to look for them for fire and deflagration, or basically explosions, and each building space that contains combustible dust. So we need to look into storage, we need to look into the final product, we need to look into the process. All of this is covered as part of the DHA. We need to go and assess every single one of them. And for the buildings, we're going to look into dust migration, deflagration propagation, the fire hazard, the deflagration hazard, and of course, look into the housekeep against accumulation. So all of this is things that are part of a DHA. That's where the challenge becomes a lot of times to do a DHA or a desktop DHA, is because you can get the housekeeping process, you can get your procedure for housekeeping, but not necessarily it means that this is going to be implemented when it comes in. So that's where it becomes a little bit more of a challenge to do those over the desk assessment. So one of the things that we look as I mentioned, is we need to assess the hazards in buildings as part of DHAs. So as I mentioned, we look into that. Very simple. The material, that equipment has combustible dust. We need to look into that. We need to look into evaluation, what scenarios can come from that. But when it comes to buildings, is where we need to look. Okay, let's determine accumulations. Do we have the intent to operate this above or below the accumulation levels that are accepted? Okay, we need to determine the actual intent dust accumulation amounts, and then we evaluate those against housekeeping practice, and then we can specify actions if needed, right? Great. This is the initial part of DHA, determining every single thing, just postulate the scenarios, what can happen. Now we look into ignition sources, right? What ignition sources I need to consider? Do I need to consider hot work? Do I have permits for doing hot work? Trucks, hot surface, open flames like an oven, fuel fired equipment, heated equipment. Because if you think about it, we even talk about some of those as part of the testing. If it goes above a certain temperature, and that's the auto ignition temperature for the cloud, I don't really need a flame per se. It's above their auto ignition, that material can catch fire. Then we're talking about electrical, impact sparks, frictional sparks, electrostatic discharge. There's different things that we need to consider, right? One of the assessments that we do as Sigma as well is electrostatic hazard assessments, where we come in and we measure what's your electrostatic. We have cases where you think your shoes are spark proof, and then when we test it, we figured out that no, you can actually conduct enough that will actually create an ignition source. So all of this is things that are ways that the industry has been evolving to actually prevent dangerous things from occurring. So just by NFPA itself has an energy for regular activities, corona, rush discharge, bulk in discharge, and then sparks, and then you look into that against the minimum ignition energy for the material. So let's say that, for example, my minimum ignition energy is 10 millijoules, right? Okay, then I know for a fact that anything that is over that, or the 1 millijoule, or everything that is over that line over there can create an ignition for that material. So I need to evaluate that, right? So I need to understand and remove them from there. Great, so we're talking about this. We're talking about ignition, we're talking about postulating the accidents. Now we get to the part of doing the assessment. How are we going to do this assessment? So the way that I said is I'm going to cover two ways, basically. The first one is basically a risk-based approach, where we're going to employ a risk ranking matrix to prioritize the implementation, right? It can be a matrix that's 4x4, 5x5. I saw a matrix 8x8. The more layers you have on this matrix, the more complicated it becomes the definition about, okay, is that an A or is that a B? Is that a D or is that E? So that's where it becomes that the most notorious acceptance in terms of like reasonable size matrix is a 5x5. 4x4, 5x5 is usually the ones that people tend to focus on because they become a little bit easier. As you can see, for example, 1 through 5, I say first minor, first aid or minor injury. restricted work, serious or lost time, simple fatality or multiple fatalities. And then in terms of likelihood is practically impossible, very unlikely, unlikely, sometimes likely, somewhat likely, and very likely. So it becomes a little bit easier for me to say, yeah, no, this is not going to happen. So I have seen matrix that say it happens once in the industry, it has once in the life of our company, once in the life of the facility. So all of this is things that will actually give you that to do it, right? So in a nutshell, what we try to do here is ranking a risk. So let's say I get, okay, if I have a release from this conveyor belt, what is the likelihood that will occur? Okay, my likelihood is unlikely, so it's a C. And what is the impact if it happens? Oh, if it happens out of the conveyor belt, it's going to release quite a bit of dust. It's going to be possibly find an ignition source around here, and then we're going to get probably a fatality. Okay, then we're talking about a severity of 4 and a likelihood of C. So we'll get on the yellow line over there, which is alarm, but as low as reasonable practical. So, okay, do I want to make recommendations? Do I make the recommendations and we evaluate? We do not need to implement them. It's different than if, for example, I say that this is very likely, right? Or somewhat likely, that then will bring me to the red. What the red means is unacceptable. I really need to do something about it. So this is the one that I will need to do some recommendation or something to actually bring this into the yellow or the green. The green is acceptable. I don't really need to do anything about it, but sometimes people still wanted to make recommendations to improve their process. The other option that I mentioned is checklists. So allow for easy evaluation of ignition sources. It's simple to prepare using well-defined codes and standards. We have one that used to use the old standards, and we already have one that is using 660, for example. So if you want to do the assessment on 660, we can use that checklist. Or if you want to do the old standard 652, 654, it's all in there too. And then we look the answer, we cause, the consequence, we risk it, we risk rank it, and then we provide recommendations. So that's basically how it goes. So we're going to go and provide you information and provide you with valid information in terms of what can be done to prevent that, right? So this is the two that we have. So the problem that we have a lot of times, as we're talking about, is that NFPA is going to rely on us to determine where the explosion hazard deflagration exists. So that's where it goes back to that. You need someone with experience, someone that's going to do it. And it's not only the lead person, but also the team that is going to be doing. So we can determine every single possible scenario that can be occurred, and we look into them. So the terms of deflagration, we look at the particle size to deflagrate. Is that suspended in the air? Is sufficiently high concentration to deflagrate? Is that we have enough ignition, the ignition source is strong enough to ignite that? And then the explosion is all the above, and is in a compartment or container or along a whole bunch of pieces of equipment, right? So as I mentioned, this is one of the things that we do. And again, we look into physical and health hazards for all of those. And then one of the things is we're talking about the importance of housekeeping is because we avoid the dust accumulation. We designed for dust containment, right? But let's be honest, dust comes out. Dust collection can be included, but every now and then we're still gonna have material outside. So the predictive maintenance prevent those leaks, but we need to take care of the housekeeping where needed to avoid a secondary explosion. So the secondary explosion, as we talked before, is when we start the initial blast wave. It doesn't even need to be a blast. As I mentioned, it could be just a venting panel releasing that because there was an increase of pressure inside the system, and before an explosion occurs, it does use that vent panel. And from that vent panel, we can disturb the dust that is accumulated, and that can be ignited, and a secondary explosion can happen, which is worse in that case. So a successful prevention, right, and a successful DHA doesn't stop right at that first step. We're talking about determining the combustibility and explosivity of the materials. This is required by NFPA that you need to evaluate and test your dust. We are going to identify and assess the fire, flash fires, and explosion hazards. We're going to manage those hazards, and we're going to communicate those hazards to affected personnel. This is a cycle that needs to be coming back because that person that can be affected, he is also a catalyst to come back and say, hey, I know we're not supposed to have this, but it's coming around. It's having accumulation of dust over there. So it's a continuous process to try to implement this. A DHA, to be successful, should be included a management of change in the end, that any major changes trigger a redo on this DHA. Or every 5 years, you're supposed to redo your DHA. So it's similar to what we're talking about PHAs, and the management of change can help you that, right? Because the fugitive dust can lead to 3 hazardous classifications. One is the electrical classification, that we can prevent sparks, and we can prevent ignition or self-heating of the dust cloud. The second is the fire hazard, where we determine the separation, the fire protection, and assess the need for PPE. What kind of PPEs I need for being in that facility, in that area. And the flash fire hazard area, which is the segregating, venting, egress for that, right? So when we talk about area classification or hazard classification, one of the things that comes into to light as well is area classification, right? So dust accumulation impact the area electrical classification. So I need to be mindful that once I do have dust as a possibility to get out, or possibility to have dust in there, I need to determine what kind of protection systems I do need. Do I need to have ATEX equipment? Do I need to have explosion-proof equipment? What is needed from me to actually keep that operation and the process safety, right? So NFPA 499 says that you should test your dust, and then if for a go, no go, an explosion. If it is a go for explosion, then you need to do the area classification. If you don't, if it's a no go, then we can skip and say that we do not need, because here is the results from my material. Here's the final report. If it is, then we need to apply that, right? So NFPA has 3 different area classifications or classes. Class 1 was flammable gas or vapors. Class 2 is combustible dust, and class 3 is combustible fibers or flying, right? In a nutshell, if I take the 499, which we're focusing on dust for this webinar, if I take this dust area classification, it gives me 3 divisions for the dust. Depending on the dust, is a E, a F, or a G. You can see that NFPA 499, it actually lists a layer or cloud ignition temperature for different materials, and it gets a division group for that, or a zone group. Why do we use this, right? The first one is the layer of cloud ignition temperature. We know what kind of ignition temperature we're going to need to actually do it. For the area classification, the dust type, it gives me which diagram should I do to do the electrical classification. So this is just an example. There's other diagrams in there, but I just wanted to highlight just quickly class 2 division 1 and class 2 division 2 for groups F and G dust on your left. And you can see that we're talking about a 20 feet or 6 meters from the equipment as a class 2 division 1, and then at 10 feet of an extra class 2 division 2 for groups F and G. When we're talking about groups E, what we're talking about now is the whole area, or the whole 30 feet, to be basically class 2 division 1 area. Things that allow us, and that's where it becomes valid after the implementation. Even if you do an electrical area classification as part of the design, after it's implemented, after a little bit of operation, it's good to come back and assess that, because you may have say, oh, we don't have accumulation on this area here. But let's say that after you come and inspect the plant, actually there's a dust a little bit over 1/8 of an inch, or basically a little bit bigger than 3 millimeters. Then this area that was technically unclassified needs to be classified now. So all of this is things that need to be taken into account when you're doing your area classification. So some of the advantages that we as Sigma can present in this area is that we have a comprehensive support across all stages. We have experience doing every single thing DHA's hazardous area classification, from concept design all the way to facilities that are being operated for years and decades. We have a proven expertise in DHA. Our consultants have over 30 years of expertise in this area. Our approach blends standard with advanced techniques to allow for more realistic results. We try to recommend things that are reasonable and not something that tells you that you need to re-retrofit this equipment or this building or this room. And we try to do cost-effective solutions. So we try to balance things and making everything reasonable for you. With that being said, I open the room for questions. If you have any questions, please feel free to ask them.
Thanks, Vinny. Appreciate that. Please add your questions to the section to the right, and we can get you an answer. One of the questions in here, Vinny, is everyone required to do a DHA, or how do I know I need to do one?
So you gotta be required to do a DHA to determine, I mean, again, you can do the testing, and if your testing say that this material is not explosive or not flammable, then you can simply just put a note saying there's the testing, there's not needed for that reason. If you have combustible dust, it is required by OSHA, at least in the US, that you do carry a DHA.
Yeah, and actually OSHA will use the general duty clause, right, to
Correct.
To point towards NFPA. Yeah, so and I guess one other note on there is if you have explosible or combustible dust in the facility, then the DHA is required.
Yep.
But like Vinny said, get the testing done and you'll be all set.
The first step, a lot of people come to us and say, hey, I want to use generic data. I'm like, look, the no go for your dust, it's a very simple, very cheap test, right? You're talking about like what, Mark, $500, $1,000 to do a go no go. So in all honesty, why not test it and be sure that you are okay or not? Because guess what? You can be saving yourself a lot of money just by testing that and say, hey, we're not explosive. So can you write it up something with this test results? I'm like, yep. You know, so it's a simple thing. It should be the first step for anything, to be honest, because flammables are great because we have the information, widely information about LFLs, UFLs, and different things. The dust, I mean, if you think about it, back 15 years ago, no one cared about what was happening on until we started having a lot of things happening, right? It tends to be things that people are not known, right? Sugar is flammable. Wheat is flammable. Iron is flammable. Things that you normally will not think, you know, that could be a flammable hazard. So my suggestion is always like test it. Be sure that you are okay. Be sure what you have on your system, on your plant. And again, it's at least the initial testing is going to be very simple, very, very cheap. When you think about what you spend on studies, honestly, even if you test the whole shebang, it's not going to be as much as you're going to pay for a study anyway. So first step for me, always suggest, even when we come in and we got to do with generic data because you don't have a vendor yet, etc. We say in the end, can you do that? Yeah.
Well, and that's a good point about the difference between vapors and dust, Vinny. Where vapors, we is a known entity, whereas the dust, because of the difference in particle size and shape, there's going to be you're going to have a varying result. Whereas we know what gasoline does. So.
Yeah. Exactly. So I have a couple questions here. I'm going to go through them and then we can. So we do give a training. The first question: do you give training on the new NFPA 660 standard? We're happy to do it. It's still not finalized. There's still a lot of items open, so we can do it as a beginning part of it. But of course, once things get implemented, we're updating our training material with that. The second question was like, if I can say something about the risk-based approach for DHA. I'm a fan of risk-based approach. The reason why I'm always a fan of it is because you rank your risk. You can rank your risk and you can determine where to spend your money and where to do it. If you just do a consequence base, or if you do just like what is the hazard? Okay, you're gonna end up with a lot of recommendations, and some of them may be exactly like, okay, I don't really need that because it's a small risk. There's not gonna be injuries. So that's why in the end, I always like to go in terms of going into the risk-based approach. So any kind of dust is not necessarily explosive. Like sugar or all-purpose flour, explosive in nature. Yes. A lot of dust that you think are not explosive in nature, they are in reality. Sugar is one example. Take imperial sugar, a sugar manufacturer facility here that ended up with several fatalities based on just an explosion of sugar. There's some of them that are ammonium nitrate that everybody knows is explosive and is very severe, but it's like things that you don't necessarily think about it. Milk powder and things like this can be, you're building a new woodworking shop or sawmill. Once you see a classification before, they will give you a building permit. How can you test the wood dust when you don't know what we'll actually have? That's an excellent question. And that goes into the point that we're going to probably need to do one based on generic data, or get a similar facility that would do the same process, had the same raw material being provided. That's the only way that I can think of doing this when you don't have it. Or because the issue is like wood dust is going to be flammable no matter what. So the problem is what the nature of your dust compared to others. And that's where the generic data is probably going to be used first before you build that and start using. But eventually, my suggestion is that eventually test it out and reassess your DHA. You don't need to redo it. You just need to reassess and say, yeah, it's still valid. No, it's not, because my dust is not as explosive or flammable as this that we use. So we can reassess some of the risk. And then will the presentation be shared? More than the sharing of the presentation, we are working on recording. We always record our webinar, and the recording comes to you guys. So it's the presentation that is going to be part of the recording in a way. So
yeah, I'll send that out directly to everyone once we have that recording. So it should be another day or two, and then you'll see a note from me with that recording link.
And I think I got it all. Did I miss anyone?
Yeah. Yep. Another one is what steps are involved in conducting a DHA?
Oh, good. So the DHA will require you, again, you can skip the testing and use generic data. But our suggested approach is always like a testing. And then we identify all the scenarios. We come in, do the checklist. We tend to do the checklist even if you decide the risk ranking. It really doesn't add that much, and it helps us identify scenarios. And then from that, we risk rank either as a workshop kind of setup. It's my favorite way to do it, to be honest with you. Or we can do as a desktop exercise of risk ranking. I like to risk rank things and stipulate all the scenarios together as a team, just because it makes more brains work better than one brain, so that's what will be. And then we wrap it up, the DHA, as a report.
And looks like one final question here that I'm seeing here, Vinny, is how often should a DHA be completed?
That's my favorite one, actually, Mark. So the DHAs by requirements is 5-year cycle, right? But I'll say it's the same as I say on PHAs. Do a management of change program, because it will help you understand when a major change was triggered, and then I can change this and redo the DHA. Because think about this, if I change my raw material provider, then it may be different, the dust that I have. The dust may not be as flammable, or maybe even more flammable. So that's basically what is the requirement in my head.
Yeah.
So the 5-year requirement comes from OSHA, not NFPA. So NFPA, that was another question here about just pop in. Does the 5-year requirement comes from? It's from OSHA, not NFPA. NFPA doesn't have and OSHA does not require you to do an FPA. Let me clarify this. OSHA requires you to do a DHA, or required to do an assessment. We tend to use the NFPA because it's a widely accepted standard and is used across several industries. So that's why we tend to do that.
All right, looks like we're good on the questions here, Vinny. So want to once again thank you all for joining us for our discussion today covering dust hazards and risk mitigation. Should you need any assistance with testing and or process safety support, please feel to reach out to me directly, but we also have a general info box at info-us@sigma-hse.com, and we look forward to being a resource to you.